Look, supposedly it went through. I don't know if it's true or not. I guess we can check over here. Are we up and streaming? We are. Sweet. Hey, so if you have questions, I have chat up so I can answer those. Not for you guys, but if anybody's watching live. Then there it is. Can I change the title real quick? Edit. Oh, I can. This is second. APCSA. What are we doing? Functions. Functions. Strings. And characters. Save. All right. Let's go to work. Let's do some stuff. And y'all said these are helpful, yeah? So it's helpful to go by the little PowerPoints, look through stuff. Do y'all like the examples still? Examples are good too? Okay, do that. Oh, look, we're not there. We stopped here. Did I talk about null? Should I talk about it again? If you want to. Really, should I talk about null? Have you seen null? Yeah. So like, look, I'm gonna show you. I like coding. What did I put in this folder? Showing off Java. Perfect. That's what I want. I want to show some Java off. All this trash stuff. Gonzo. All right, check it out. So I make a scanner. I call it scan. And then I can just S out the scan. And if I didn't make a new one. Yeah, right anyway. Oh, it's an error. Okay, wait, hold up. There we go. So if I can have a scanner, and sometimes it doesn't like that, I'll show you the error in just a minute. But what I'm doing is I'm saying right now this scanner is nothing. It's null. And then later on, I can do this. And it'll print out like who it's reading from. And this is all. You just have to trust me. This is all information about how the scanner is reading things in, which I'm not going to walk through today. But all that to say, if you want to say like, don't assign yourself to anything, just have nothing in that place, then you can use the word null. Good? Yeah, we'll play with it later too. But here, look, I'll show you this too. All right, right here, it says the variable has not been initialized, and you're trying to use it. So if you ever see that error, just make it equal to null. It's the practical. You don't have to actually make do y'all know what initialize means? Should I do like a vocab thing real quick? Initialized is when you make a new one. This is initializing. This is declaring, by the way. I'm declaring that scan is a scanner. I initialize scan to be a new scanner. So, yeah. All right. So to fix it, I just say equal null. We're good. Cool? Yes, no, yeah. Sometimes Java defaults to you just automatically be null. I guess I should put, oh, hold up. I'm gonna fix this. Because I have had this happen. I'm just gonna delete that. We'll delete it. There we go. You know when you have those comments that are sometimes true and you think, it's better just not say it. Yeah. Y'all get what null is? All right. Void functions. Have y'all done functions before? Should I act like you haven't? Yeah? All right. So void functions are functions that get the job done, don't give me anything back. So like, if I were to say, I don't know, somebody close the blinds. Am I expecting you to turn anything in with that? No, I just need you to go over to the blinds and close them. If I say, go turn on all the computers, do I need you to come back to me with anything? No. If I said, do your math homework and turn it in, am I expecting you to give me something afterwards? Yes. So that would not be a void function. So void functions are when you ask for the computer to do something, but you're not waiting for any answers or any response. Good? Yeah. So like print line is a void. It just does it. Just print it. I don't need you to give me anything back. I don't need information from you. When we're doing work with array list, like those list of blocks that we were making in Speed Racer, if I wanted to clear my list out, I just tell my list, hey, clear this out. And I don't need him to come back and tell me anything because he did it, cleared it out. Right. Yeah. Any questions on that? Okay, the opposite of a void function is what? Any guesses? What? It's a return function. Because, you know, void means you don't return anything. So the opposite of not turning something in is turning something in. So if I were to say, like, tell me your name, turn in homework, get a gallon of milk from the store, like even something like this, most of the action is getting a gallon of milk from the store. Most of the action that I ask of you is to, like, get in your car, drive there, find the milk, purchase it, drive back home, and then only at the very end do I need you to turn the milk in, right? So the bulk of the action is not the turning in the stuff. The bulk of the action is actually the execution of what you've done. But I still want something from you at the end of it. So things like math.random, that'll find a random number from 0 to 1. Floor, round down, abs will give you absolute value. Those are all things that we expect to have an answer at the end. Would y'all like to see coding examples of this? Yes? Okay. Oh, this is perfect. Int num equals scan dot. Okay, so let me show you. These are all the things that you'll get back. So if I ask for next int, what will it give me back? What, right here? Integer. And if I ask for the next double, it'll give me back a double. And if I ask for the next word, which is next, what do I get? A string, which we'll talk about in just a minute. Or the next line gives me back a string. What is something on here? There are 3 functions that will not give you anything. What are the 3 functions in the screenshot that won't give you anything? That notify has a void, which means when you ask it to do it, it will not turn any work into you. Notify all and remove. Another one that you guys have been using often is closing. Get the job done. I don't need you to tell me about it. Right? Was that helpful? To see those, talk about those types? Yeah. So on NetBeans, you can always just look over here and it'll tell you what type it is. And so you know what it should be giving you back. Which is useful. If we do math dot, it does it too. And NetBeans will actually sort it for you, and they'll say, if you're going to hold this as an integer, here are all the things that return integers. And that's why all the int ones are first, and then everything else is alphabetical after that. So, okay. Non-static. Okay. This is tough. This is something that I didn't get till like I was out of college, because nobody explained it to me right. But hopefully I explained it to you right, and you're cool with it. You ready to give it a try? I'm ready for it. Let's do it. All right. So static, non-static, are functions that require you to make an object to use it. So like scan.next. So, yeah. So examples of that would be like in real life, like what's your birthday, what's your address, what's your parents' phone number, how many people live in your house. And the interesting thing is that like if I were to ask 2 or 3 of you how many people live in your house, it would be very rare for me to get all different answers. Right? Like if average household size is 4.5, right? So it would be very weird for me to expect different answers from everybody, especially if I had a class of like 30 students in the room. And I'd be like, okay, somebody's got to have 30 people living in their house if I'm expecting unique answers. Right? So non-static doesn't mean that everybody's different. Non-static just means the answer depends on who you are. Okay? Static functions are functions that the answer does not change no matter who you are. Who's the president of the United States today? Okay, you can lie. You can tell me who you would vote for. But in order for you to be correct, you can give no different answer than anybody else in the room. Right? What's today's date? Now, if I said, who do you have for your 7th period class? That would be a non-static function, because that would be asking you something that is dependent upon who you are, right? But if I said, what is the name of this high school that we're in? Like, there's only one answer for that, and everybody can give that one, right? So that is a static function. Now, how you use them is very different. So, math dot. If I call a class like math, all of these will have the word right here, static. That means that you call it from the class itself. Now, if I were to go to scanner, there's nothing there, because all of scanner's functions are non-static. They depend on what the device is actually scanning. So if I tell it to scan a file, it's going to have different answers from if I tell it to scan the keyboard. Yeah? So none of these will have the word static, because these are dependent upon the individual scanner giving its appropriate answer to that question. Have I explained that well to you? Do you all understand the difference? Yes, no, maybe? We good? Should I like get a poll from y'all or something? Y'all gonna respond? You did, good. I'm just gonna assume I got it. I aced it, right? Nailed as a teacher? I'm fine. Okay. I'll find out when I give you an assignment. Or a test. That's even better. Okay. Pushing forward. On we go. Characters and strengths. All right, we got to talk about this. I actually had to Google the maximum number of characters in a string because I was interested. All right, check it out. This is a character. It's called char. C equals, and it will hold one ASCII value. Mr. Barrett, what's an ASCII value? Oh, that's a cool question. Let me show you. ASCII table. They're letters. And like some of them are sounds too. See, bell makes like a little beep. Most of the time it's just letters. These are called characters. And that's, yeah, and each of them is assigned a number. So the number's on the far left. So like what letter is assigned to 86? What? Not just V. Because one of the V's is 118. Yeah. Capital V, uppercase V is 86. Lowercase v is 118. Yeah? So they all have a number, which is cool. We could use that too. I'll show you in a little bit. No, I'll show you now. So if you remember how we talked about typecasting? So if I turn the number 86 into a letter, it gives me the V. If I turn the number 85 into a letter, I get a U. Yeah. Yeah. So this is how like typecasting is pretty nice. The other thing that you'll end up doing in some problems, I'm sure, one day, is like so I could ask, like, how many letters from after C would you like? Make a new scanner. So this would be like a problem I give you all period to work on. We're just going to do it real quick. Yes? So you can say it num. So the letter C, I don't know what the letter C is, but we're going to figure it out, because what I'm going to do is I'm going to say int C plus num. It works. I think 3 letters after C is F. C, D, E, F. Yeah. Well, let's do 1. I should get a D. Yeah. So, should I explain how this works? Yeah? So, if I get the integer value attached to capital C, the integer value attached to capital C is what? 67. So we do 67 plus 1 is what? So this is all 68. And then we say we want the character value of 68. So you go to the table. What's at 68? D. The real only thing you really need to know is that 65 and 97 is the A's. Because once you figure out what the A's are, then you can just do all the others, right? So 65, 97, those are your A's. If there's another letter that you like better, that's fine, memorize it. But you only got to memorize 2 letters, because you can figure out everything else after that. If you're like, my name starts with a K, so I want to memorize that one, then by golly, you do that. K is 75 and 107. But A's are 65 and 97. So, all right. A string can hold 0 or more characters. It's just text. So here, let's make some strings. So I could have string numbers. blank. Word. Sentence. And all of these are valid strings. I could even do I could even add them together, make a bigger one. Oh, I go 6. See? Just combos it all together. So you can jam strings together and save them and all kinds of stuff. Treat it like numbers. Oh, but interesting thing. What happens if you do this? What's it going? What will it do to the printout? It'll add a 2. We gotta get rid of this little thing. I need you to back off. There we go. All right. So it adds a 2. But what happens when I do this? Because 2 plus 6 is 8, right? But it prints 26. Why does it print 26? That is an integer. 2 is an integer. Do y'all understand what he's saying, or should I explain it? I should not explain it? You understand what he's saying? Okay, so I should re-say it, right? All right, so most of us look at this, and we say 2 plus 6 is 8. But that's not how the computer sees it. When the computer looks at a string plus 2, it can't make that all into one number. It doesn't know how to add 2 to that number. And so what it does is says, I guess what you want is you want your sentence with a 2 tacked on the end. And all of this becomes a string. And then it looks at the 6 and says, I don't know what number all of this with the 2 at the end should be. And so I guess you just want another string. And so it makes one big string. However, if you put parentheses here and you tell it to evaluate the 2 plus 6 first, then it will make this 8, and then it will say a string plus 8. I don't know what you want. I guess you want a string with the 8 at the end. And so this would make 8 at the end. Is this helpful? Yes? Okay. And the AP test loves to give junk like that because they want to know if you know how things are evaluated, right? It should be an easy question. Lots of people miss it, so don't miss it. The other thing they like to do is stuff like this. Let's see. 7 divided by 2. What's going to print out? What will be the last letter? What's 7 divided by 2? No! You wrong. I don't mean to be offensive. If you're offended, I'm sorry. Why is it not 3.5? Because when a mommy integer and a daddy integer get together, you get a baby integer. It'd be silly to get a baby double. So 7 divided by 2 is 3. Good? I'm going to keep saying that, and you're going to be like, this is so dumb when you talk about baby integers, but when you take a test, it's in your brain. It's like, what? Hold up. I know this one. All right. Good. All right, there's there's actually some static and some non-static string methods that you will want to know about. So I'm going to show you. You may want to write them down. Oh yeah. You may want to write them down because I'm going to walk through these and we can talk about them, and then I'm going to show you a couple other ones that you may find useful in assignments later, you know, in the next week or so. Hint, hint. All right, so if I have a string S, it'll just make a copy of that string. I can ask about the length. Would you like me to do this for real in code? Yes. So let's say like sout numbers dot length. So how many characters are there in numbers? This one right here. 3. So I get a 3. Yay. Good? Yep. All right. What's the next one? Substring. Okay. So substring is fun. Let's do the word. Okay, so if I want to skip the first letter and I want to just go to the end of the word, then I could do substring 1 and it will skip the first letter. What's actually happening is computers start counting at 0, so it starts with the letter 1. Right? Because this is letter 0, and this is letter 1. Now, if I wanted to stop right before the third letter, or right after the third letter, because it would be right before the B, right? Because 0, 1, 2, 3. So if I want to do a substring, I give it 2 numbers. It cuts 2 places instead of just 1, and so it would cut after or before the first letter, and before the letter 3, because this is letter 3. Y'all get that? Do y'all want me to draw it out? Do y'all understand the numbering of the letters? Yes? No? Over there? Y'all are good? Okay. I'm gonna skip. I feel uncomfortable about this, but we'll go with it. So this is how you chop it up. I'll find out if you know how to use it later on, because it'll ask you about it. You'll have to make programs with substring all the time. And we did this one already. Index of. All right, word.index of. Let's look at that. So I can get the index of O from sentence. And I can find out that the first O is at spot 4. So 0, 1, 2, 3, 4. Yes? Now, if I want to find the location of the OR, that is all the way at spot 11, because that starts here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 starts on spot 11. Okay? Let me check them real quick. Yeah. If I want to find where the last O is, I can do the last index of. And it'll tell me where the last O is, which is at spot 11. Okay. If there's I want a letter that's not there, it'll give me a negative 1. So, how would I get a substring for if I had a word? How do I get a substring for the W and the 2 letters after it? So how could I get a substring from word, any word I give it, with a W and the 2 letters after? All right, so the first thing I would want to do is find out where the W is, right? And then I can say sub end. Where does my substring end? And it should be W location plus 2. Yes? And then my string, my substring, hey, that's supposed to be a semicolon. Oh, I should have done 3. Barrett. Barrett, why'd you have to do 3? Because if we're cutting right here, we want to cut 1, 2, 3 locations after that. So, but let's change the word. What's a word with a W in it? Worthy? Word. Fine. Or waterfall. Or swish. It doesn't matter what the word is. It finds the location of the W and the 2 letters after. Good? All right. Equals. Oh, y'all. Y'all. Okay. So this should not print out true. Oh, it did. Java, I hate you. Pretty sure this will work. You guys probably think I'm like this scrub and you wish that you had your old teacher back, and you're probably right on the scrub thing. But the way they handled their Java, the way they handled their strings is notoriously terrible. Because I hope that this will be false. Yeah. So here's what happens. Can I give y'all like the science lesson behind it? Draw some pictures, show y'all what's going on. All right, look, here's what happens. So it's just so stupid. They did a terrible job. I mean, maybe. It fixes some stuff. Okay, so you made a string and you called it 1, 2, 3. And Java says, okay, so that's in memory right now. That's in memory right now. So I'm going to label this what you called it as numbers. Right? So good for you. That's not near what it's supposed to be. There we go. That's number. So then every time you make another string called 1, 2, 3, it says, why do I have to save the same string multiple times? For example, if I were to make a database of all the students' grade levels, freshman, sophomore, junior, senior, there are a ton of sophomores. There is no reason for me to individually hold the word sophomore for every single sophomore, right? When I could just say, it's that word, and just hold the word one time. That was their thought process. So, if I were to create 1, 2, 3 again, with num, there we go. But what I did to trick it is I did 1, 2, and I saved that as num2, and then later on, what did I add to num2? Then, later on, I added the 3 to it, but now they have different places in memory, and so now they're identifying as different things because they're different places in memory. When you ask the equals question to anything that's an object, you're asking, are they equal places in memory? Right? Which I think could do fun things. We'll test that in just a second. Do y'all like testing? Do y'all like breaking things? Not like taking tests, like breaking things. I can try to break something in just a minute. You guys won't be like judgmental or anything, I hope. We're going to try to break it. It's going to be fun. Okay, so when I did that, what this asks is it says, are they at the same location? If you want to ask if they're actually equal to each other, anything that's not a number, you have to ask the question, are they equal? You have to ask the string, are you equal to this string? And it will tell you yes or no. And there we get the yes. So, long story short, don't use equals on anything that's an object. You have to use dot equals. Is that good? Yes? Okay. Let's try to break it real quick. Let's change this to 1, 2, 3. And let's print out the original. Sometimes it breaks. Nope, didn't break. But if I do num2 here, okay, can y'all tell me why I think it might have broken? Based on the picture. Why is this? Because if I were to take this right here and move it up before I add it, it'll print true. It's so dumb. Like, this is the one thing I hate about Java. So, do y'all need me to keep tell you what's going on? Yes? Okay. So what happened is we have, let me fix our naming conventions here. We have numbers, and I call this one num2. Select. All right. This is gone. So we put them at the same place, right? So do they point to the same location? Yes. Apparently, because they were worried about this, they said, if you do anything to the first guy, we're going to just quickly make a copy and let you add your 3. And under the hood, you'll never know. Dum, dum, dum. That now it goes here, and that link is broken. They do sketchy stuff like this all the time in Java. It's really frustrating. Do you understand what I'm saying, though, behind the scenes? Yeah? Which is totally different. Like it's different from knowing how to drive a car and knowing what's going on under the hood of a car. Right? There are a lot of people in the world that can start a car, get to where they need to go. But there are a vastly smaller amount of people who start a car and they know all the processes that happen to get that car to move. Yes? So. And sometimes they're like, yeah, my AC goes out sometime, I don't know why. And some people go, my AC goes out sometimes, I know exactly why. And so the goal of this class is to get you to the second. Like, I know why this is doing this. I mean, it's computer science, not programming. All right. Do you have any questions on this? We've tested it, played around with it. Actually, what happens if you change the original? Oh, cool. So apparently it has something that says, like, if any 2 people are looking at this, then we'll split it up. That's nifty. Compared to, I've killed that horse. That's a dead horse now. Compared to lets you compare strings. So, if you want to have alphabetical order, We're going to erase all this other stuff. I want to start over. Boom. Look at that. Give me a letter. Give me a word. Starts with an A. Apple. Give me one that starts with a B. Boomerang. Got it. Thanks. C. Character. All right. So we're going to say if word 1 is less than word 2. I don't know, R. And it says you can't do that. All right, so to compare words, we have to use a compare to function. Here's how compare to functions work. If it's less than 0, then that means that the first word is less than the second word. So you're going to ask a word, are you less than, or compare yourself to this other word. So in the alphabetical sequence, apple comes before boomerang. Yes? Make sense? Now I can ask it if it is, if it thinks it's greater than, if it thinks it comes after alphabetically than the other one, and it won't. But word 3 will say that it does. Huh? And if it's 0, it means that they are equal. So I could have like and I could say less than or equal to, which by the way, if you ever want to ask if something is or greater than or equal to, if it's greater than or equal to, just put a greater than and then an equal. I saw a lot of people doing like greater than 0 and equal to 0. So I just thought I'd throw it out there. Saw it in your code. Want to fix it. All right, but you can do this and I'll put an R. Because they're equal to each other. 0 is equal. All right. Is this all? Okay, no, because I got one more to show you. At least. All right, first one. Replace the A with an A. But it doesn't do it forever. So if you want to replace something, you want to replace the P's with a, I don't know, it looks like a little P. We can do like the 4. You can replace everything with a single one, but does it save it? No. If you want to save it, you would have to say word 1 equals. And then it'll save it for you. There's also things like that works the same way. Two lowercase, two uppercase. Trim. Trim is sweet. So trim Trim will take all your white space that's on either side and take it off for you. When I was in high school, my mom taught computer office, like Microsoft Excel and stuff. And I would be bored when I was in her room in the morning. And so I would go to all the logins. And, like on, and they fixed it, but they didn't when I was in high school in like 2003. So when I was in high school, they would have username, and it would have a little cursor here, right? So what I would do is I would hit like 2 spaces and then go back 2 times. So then a student would come in and they'd be like, "Oh, my name is John," and they would hit tab, and it would go to the password, and they might have their password as like Apple, and they would hit enter, and what would it tell them? What? It's wrong. It was great. My mom would be so mad. She'd be like, "I got nothing done in first period because all these logins were wrong." And I never told her, like, I'm not a brave soul to be like, you know what I've been doing, because I was bored. Like, well, but it was wrong. And you know what John does whenever he gets his password wrong? He tries a different password because he thinks he put the wrong password in. So then like 6 times, then he's locked out of his account, and then he can't do anything for like 10 more minutes. And then eventually it resets. And so anyway, but used to, Windows would hold that space and not trim it, but they've changed it. Now, if you do that, it trims down automatically, so you can't do it anymore. But yeah, so that's a usefulness for trim. Y'all know what trim is now, yes? And how horrible I was as a high school kid. Because it wasn't just one time. It was a good number of times I did that. I was like, man, that sounds terrible. There's if you try to, I'm supposed to talk about exceptions. If you try to find a letter, if you try to like tell a string to go outside. So if I were to go to, we never talked about caret either, did we? Let's talk about caret. Character at. So in word 2, let's not do word 2. Let's do word 3. Word 3 is better. In word 3, what is the character at spot 0? C. So it returns a C. Now, the character at spot like 6, be T, and the character at spot 99, is there 99 letters in the word character? No, so it's going to be like, error, stupid. And it says there's a string index out of bounds error. And so sometimes the AP test likes to ask, what kind of error are you going to get? But it totally makes sense because you're asking for a letter that's outside of the word. Right? Get in your lane. Don't do that stuff. All right, last thing. Rapper class. Yo, yo, yo. I'm a cool guy. Not that kind of rapper. Text. Give me a number. 42. All right. So if I want to make this, if I want to know what they typed, but I want to do like 42 plus 3, how am I supposed to turn that to a number? I use a wrapper class. You and your example, Barrett. There we go. 45. If I turn it into a decimal, then I would have to do double. Double. There we go. Later on, we'll do things where you have strings and you got to turn it into numbers. It's super easy. This is how you do it. We good? Yes? No? Yes? Okay. All right. You want me to walk you through the program you have to do today? Would that be helpful? Would be nice? All right. So what I have y'all doing today is Spellbinder. Here, I'll show it. So we'll talk about it. So Spellbinder, what's going to happen is it's going to ask you. It's going to give you three words actually. So you'll have the original word, and what they want you to do is they want you to take the second word, and they want you to replace it with the third word in the sentence. So you take the M and you replace it with the C, and you would print out custard. So you're going to get 3 words, and then you're going to swap it out. So the J in junk turns into TR, which makes trunk. And so you should use one of those string things I talked about. Maybe more of them. I don't know. But at least one. Lots of good ways to figure it out, too. So there's like probably 3 or 4 really good solutions. You just got to have one. Do y'all understand what you're going to be asked to do today? Yes? And there's a little matching quiz for math operations. So y'all can get that done, too. Any concerns? Let me check stream real quick. I don't think I've seen any comments. Nope, no comments. All right, well, get to work.